this example in here that they have on this growth of this bacteria in yogurt is an example of how you can apply exponents. Populations that grow, whether it's human beings or animals or bacteria, whatever, often grow exponentially. Now, not that we're going to get into in grade 10 all the specifics of that. They do give you a formula here, which is an exponential equation here. And the reason it's an exponential equation is because of where the variable is. This variable here, this h, is in the exponent, and that's what makes it an exponential function that we're looking at here. This formula has two things in it. It has n, which is the number of bacteria, and it has h, which is h hours. Usually, actually, that's a bad idea using h for hours, using the letter that you would use, the units. Like often you would use the letter h for hours, so it might be better if this was a t, so I'm actually going to write the formula with a t here, but you can have it however you want there. If you work with this, there's n and there's t. It says, what does the value 2 in the formula tell you? Well, again, without having studied exponential functions, you guys might not realize, but if you started with 10,000 bacteria, so this is the only background you get here. If you started with 10,000 bacteria, and it says every once in a while it doubles, that's what that 2 is. If you times it by 2, at some point it doubles, at some point it doubles again, and so on. You double it every, I don't know. In this case, you're going to double it every 42 hours. That's what that 42 represents there. But not that we know that. But that is a formula that you can substitute numbers into and work things out. I don't know what I'm going to put here. This is maybe not a reasonable question to ask you if you haven't actually studied exponential functions, but it's in there. Doubling every so often. You're multiplying it by 2. But it says how many bacteria are present after 42 hours. The idea is that you can replace the time, sub t equals 42, into the formula. So write the formula, 10,000 times 2 to the power of t over 42. But instead of the t, I'm going to put in 42. Well, this one you can kind of figure out what it's going to be without even maybe doing too much in the way of math here. What is this exponent up here? If you put 42 in, what's that the same as? It's 1, right? Now, we got to be careful with our order of operations here. Not that it matters if this is a 1, but you want to evaluate the power first and then do this multiplication, right? Exponents come before multiplication. Times 2, there's going to be 20,000, right? 20,000 bacteria. It doubles every 42 hours, and that's how this formula ends up getting set up. But again, not that we're at that stage now of being able to write those formulas. If it says present after 2 hours, well, you can still substitute in the 2 and figure out what it's going to be. Just sub in t equals 2. Okay, so if you have the number of bacteria, 10,000, 2 to the... Now, this is tough, and I was even commenting on you, and I'm not doing a very good job of it here. It's probably, right big enough that you can keep this thing as an exponent, something over 42 up here. If you put 2 over 42, if you're working with your calculator, make sure you're entering that correctly. This is not going to be one that we can work out without a calculator, because this number is not a nice number to work with. If you're doing that on your calculator, don't multiply this out first again. You got to follow order of operations. But if you have your calculator, get rid of that. You can put it all in one step if you want. You can go 10,000 times 2 to the power of, and if you're working with most of your calculators, you're going to have to put brackets in there. I'm going to put them in here, even though on this one you don't have to. 2 divided by 42. You can work it out. It's a little bit more. It's going to be obviously less than 20,000, but it's going to be a bit more here. We should round this off because it's a number of bacteria. You can't have half a bacteria in there, so I'm going to put 10,336. It's the closest number. Okay, that's what it's roughly equal to, so that's how many are there after 2 hours. Just sub the numbers in. How many are present after 105 hours? Well, same thing, right? Just sub in those numbers here. 2, 105. I guess I should stick to a different color for subbing in a number. 105 over this. I'm not going to work that one out. You can work that one out. The last one here is one of the other ones I wanted to look at. 63 hours ago. What should you do with that? All these other ones you sub in a certain number of time for hours. 63 hours ago, it's not going forward in time, it's going backward in time. What should we do? What should we put? Negative. Put a negative number. Negative 63. I know it seems weird because it's like a negative time, but 63 hours ago, put in a negative number. Okay? Negative since, because of this, 63 hours ago, since it's in the past, right? And what that's going to mean here is if we write this out, n equals 10,000, 2 to the power of negative 63 over 42. I'm gonna let's again stick with this, negative 63. If you make this simpler here, I'm actually going to do something first that makes it a bit simpler. 63 divided by 42, I actually am going to change that into negative 1.5, working out what that is. If you divide that, you get negative 1.5. If you're multiplying by this, negative power, it's actually the same as dividing by a positive power. Multiplying is going to make the number bigger. All these ones up here, the number gets bigger because you're multiplying, right? Multiplying by some number here makes the number bigger. This is actually going to make the number smaller. It's the same as dividing by 2 to the 1.5. If you really wanted to, you could write it as 10,000 divided by 2 to the positive 1.5 if you want, right? Multiplying by 2 to the negative 1.5 is like dividing by 2 to the positive 1.5. You don't need to do that because you can just punch this in as long as you do it properly on your calculator. If you go 10,000 times 2, power of negative 1.5. Oops, need the decimal there. 0.5. Okay, it should be a smaller number. It makes sense. Make sure you realize whether the answer makes sense or not, what you're doing. Should be a smaller number. It seems reasonable that it might be 35, 36, roughly 35, 36. Okay, that's obviously a rough estimate. I mean, using this model here, but hopefully you're okay with working with that. If you're given a formula and that has two variables in it, sub the number in for one of them, work out the other one. Okay, this is the reason that this is in this section is because you have this is called an exponential equation, an exponential function, because there's exponents in it, and it's giving you a situation where you can have, number one, where you can have fractional exponents. These are all fractional exponents, and where you can have negatives, right? Like the last section, negative exponents. That's why it's included here. Okay, make sure you try at least one problem like that where you're applying this stuff. All right. Can we get back to working on